One AI can secretly teach another its hidden traits, using data that looks completely innocent. It's called subliminal learning, and in 2026, a wave of papers tried to pin it down. We're going to synthesize 4 of them. What they collectively prove, the sharp maths behind it, and the real fight over whether it's a deep phenomenon or a fragile glitch. Let's define it precisely. Teacher model has some trait, say it loves owls, or it's subtly misaligned. It generates data on a totally unrelated task, like number sequences. That data is filtered to remove any trace of the trait. Yet a student trained on it still catches the trait. 4 papers attack this from 4 angles. One asks which property of the data carries it. One asks whether it survives natural language. One asks exactly how much transfers. And one asks whether it's even real or just an artifact of how we fine-tune. Lens 1 from CMU reframes it as data-mediated transfer. The trait doesn't spill uniformly. It flows along the structure of the data and, crucially, along the training channel. They compare 3 ways to distill a teacher into a student. And their striking result is mathematical. Even on-policy distillation transmits the misalignment. The student generates its own text, and the teacher only scores it with a reverse KL. No teacher trajectories, no full distribution, and it still leaks, nearly as much as full distribution matching. The clean summary from Lens 1: the teacher sets the direction of transfer, which trait moves, while the data distribution acts as a gate on the magnitude. Hold onto that split. It's going to reconcile the whole story later. Lens 2 from ETH, Cambridge, and Peking asks whether this needs weird data like numbers. It doesn't. A teacher that loves an animal simply paraphrases ordinary sentences, and its student catches the preference, by up to 19 points, from content with no connection to the animal at all. And this is the pivotal clue. It isn't the words. Paraphrases pass aggressive fidelity filters, contain no telltale vocabulary, and even work when the sentences argue against the trait. Reading the content simply cannot detect the transmission. Lens 3 puts a number on it. Steer a teacher's refusal-direction to make it unsafe, have it generate only benign data, distill a student, and measure the transfer ratio. How much of the teacher's shift the student inherits. And the amount is large but model-dependent. One model gates the leak behind a sharp threshold. Another lets it through smoothly, with the student inheriting more than 60% of the teacher's steered unsafety, all through benign data. Lens 4 from Chicago is the skeptic. It argues subliminal learning is largely a LoRA artifact. Almost all these experiments fine-tune with a small low-rank update, and the effect depends delicately on that update's rank. Their evidence for fragility is strong. The effect follows an inverted U in the LoRA rank, peaking only in a middle band. It vanishes entirely with full fine-tuning. And it's pinned to specific context tokens. Turn off the adapter at a few of them, and it collapses. So now we have a genuine tension. Lens 3 measures a robust, sizable transfer, over 60%. Lens 4 calls it fragile and artifactual. Are these papers contradicting each other? Not really, and Lens 1 already told us why. The teacher sets the direction, the setup gates the magnitude. Lens 4 is mapping exactly what that gate is made of: LoRA rank, shared context, trigger tokens. Phenomenon is real, but how much leaks is controlled by the training recipe. Put the 4 together, and a single mechanism emerges. The trait doesn't live in the visible content. It rides in the teacher's token distribution, its internal representations, concentrated at particular tokens. That's why you can filter the words and still lose. Every paper points at that same place. On-policy distillation transfers because the teacher scores the distribution. Paraphrases transfer because the trait isn't lexical. The refusal-direction is a representation. The LoRA effect localizes to divergent, entangled tokens. 4 methods, 1 target, the distribution over tokens. The safety lesson is unified and uncomfortable. Content filtering is the wrong defense because the signal isn't in the content. What actually disrupts transfer is changing the channel. Full fine-tuning, breaking the shared context and trigger tokens, or altering the distribution itself. When models train on model-generated data, the pipeline is the attack surface. So here's the synthesis in one breath. Subliminal learning is real. A teacher's direction transfers through clean data, even on policy, even through faithful paraphrases. Its magnitude is gated by the training recipe, which is why it can look both large and fragile. And it lives in the token distribution, not the words, so inspecting content will never catch it. Subscribe for more papers, decoded in full,